This one's pretty cool. I like to think, you guys know that you can like rent movies or buy movies online now?
Yeah.
Yeah, you guys know that. So when a company puts a movie online to get someone to buy or stream, they have to come up with a price, right? So you might think if you charge a lot of money, you can make a lot of money, right?
No.
But sometimes if you charge a lot of money, what happens?
People won't buy it.
Yeah, less people buy it. So you might be like, okay, so I get a lot of people to buy it if I don't charge a lot of money. But if you don't charge a lot of money,
Don't get a lot of
you might not get a lot of profits because it's a little money for a lot of people. So what you're going to look for here, using this 18 minus X, that's going to be the number of downloads in the thousands, and they found that that is related to the price here. Okay, so you're going to get the number of downloads per thousand using that, and then you're going to get how much money they make from that. Where I really want you to focus when you get to the end of it is your expression down here. You're going to graph and compare, and you're going to try to maximize profits. Okay, we're going to look for max profit. So that's what you're going to work on with your partner right now. The table, the graph, explain how you know what's what, and what would you recommend to charge for this movie. We're going to start by filling out the table, and I know I have 18 minus X is going to give me the number of downloads. So 18 minus 5 is 13. 18 minus 10 is 8. 18 minus 12 is 6. 18 minus 15, 3. 18 minus 18, 0. So I'm going to multiply my price by the tickets, right? So 50, 63, 65, sorry. 80, 72, $45, $0. And that means I need to do X times 18 minus X to get my ticket price. Everybody good? I multiply my price by the number of tickets. Okay, is this quadratic?
Yes.
Yes. How do we know?
Because X. It's also got X squared.
Right here, we're going to have an X times X, correct? It is a parabola because of the X squared term.
Wait, but how's it X squared if it's X times negative X?
Okay, I'll show you. If we were to, well, negative X is same thing. This is 18X minus X squared. It is an X squared. Okay, so just like gravity, if it's falling and we want to know distance, it's 16t squared. But if we want to know proximity to the ground, we're subtracting 16t squared. Either way, it's still quadratic. Okay, let's plot the points then. We had 315, 5. Whoa, no, I did that wrong. It's 345. Here we go. 345.
Mr. Mac, if it
565.
if a parabola
1080. I'm listening.
is a parabola always x times x?
X squared of some sort will always be parabola. Yep, that's quadratic. 1272 through 1545 and 180. I also got a 0, even though it's not on there, right? If you have a price of 0, you can't make any money. So this isn't perfect, but you guys seeing this parabola happening? Okay, so that's other proof. Okay, that's other proof that we have a quadratic. So we plotted the points. What price would you recommend we sell for?
$9. 9.
Here's what I said. Between 5 and 10, but closer to 10. Is that a cop-out? It's hard to tell exactly what the vertex is. I could actually math this thing and get the vertex, but you have not done that yet, so I'm going to refrain. So between 5 and 10, but closer to 10 is what I'm seeing, right? Somewhere up in that area. Cool. So there's a way to maximize profits. It's not charging the cheapest. It's not charging the most. So this is in your notes. We're going to practice doing number 1. In your notes, to make it fit on one page, it goes 1, 2, 3, 4 like you would read. Top left 1, top right 2, bottom left 3, bottom right 4. And we need the context. For each one of these, you're going to find some things. You're going to find the domain. You're going to find the vertex. And you're going to find the zeros. And we're going to say what they are in context as well. So we're going to find these things for each situation. So right here, we're talking about area of a rectangle. So if I'm talking about area, can I have any negative area? No, so my domain, the least it's showing on here could be something like, close to 0. 0, 0. Or 12 and a half. But would I use 12 and a half to get area? Do you think? If it's 0 area of a rectangle, does that give me area? No, so I'm going to say that my domain needs to be not greater than or equal, bigger than 0, but it has to be less than 12 and a half. You guys follow that? I can't have these down here because I'm not going to have negative area of a rectangle. Okay? So domain are all possible lengths, right? These are possible lengths. Can we have fractions and decimals for lengths? Yeah. We can have parts, right, for lengths. Let's talk about the vertex. That's this spot right here. Okay? And we're going to try to get an ordered pair for that vertex. What are you guys thinking it looks like? It's not 5. See how it's after 5? It's actually, it's close to 6 or 6.25. And it goes about 39 high. So what does this mean? What's the biggest rectangle we can make? Yeah. Biggest has length of 6, area of 39. It's just really close to it, right? We know that the perfect square is the biggest. This is close to the perfect square. It's like 6 point stuff, Hadley. But we're just looking at the graph, so it's hard to pull exactly. Yep. Okay, so this would be the biggest we can take. The vertex in this case is the maximum. Let's talk about the zeros. The zeros is where it crosses the x-axis. They are 0 and 12.5. And what do those mean in context? How much area? 0 area. Okay? So that is what you are going to do with the other 3. A domain, what it means. Vertex, what does it mean? Zeros, what does it mean in context? So you're going to apply context. Because this function up here as written includes negative areas, right? But we have to be smart and consider concept and be like, hey, negative area doesn't make sense for a rectangle. So we're not going to include that in the domain. It is part of the theoretical quadratic function if that goes forever, right? So you're going to apply context. Okay, so just know your 2 is going to be in the top right even though mine's bottom left, right? So just you're focused on number 2 right now. Let's go domain. All possible x's. So I'm talking about numbers of squares. So what are you thinking, Micah?
All numbers greater than 0.
Okay, I can agree with that. It needs to be bigger than 0. For this function, it's starting at 4 though, right? Yeah. So, but all inputs 0 steps is 4. So bigger than 4, but we need some more here. They need to be whole numbers. And here's why. Can we have step 1.5 or something? If we're talking squares and boxes? No. Nope. Step 1, step 2, step 3. So we're going to say has to be bigger. I messed that up. It's not bigger than 4. It's bigger than 0. Or equal to 0. We can have step 0. Okay. That 4, that y-intercept got in my head there for a second. So it needs to be greater than or equal to 0. We got step 0, step 1, step 2, step 3. Do we have negative steps? No. So we're really just looking at this part of the function, right? And how far does that go on for? Forever. But I have greater than or equal to 0, so it works. Okay. Next thing we have is vertex, which is this spot right here. And my vertex is 0, 4. If you can't tell from the graph, check out my y-intercept and my function. Okay, so what does that mean? Step 0 has how many? How many blocks? 4 blocks. That's my constant. That's one of those squares that we're drawing, and there's always 4 extra blocks every time, maybe on the corners. I like the 4 blocks on the corners. And last, we have zeros. Where's this one cross the x-axis? Never. There's no zeros. This one will not cross the x-axis. There'll never be 0. Cool. Let's go to number 3. Number 3 is the distance an object has fallen. Okay, so let's go with the domain. What are possible inputs? Someone other than Micah. I appreciate it, Micah, but what are possible inputs? So it looks like x is time. What are possible times of this thing dropping? 2 is that's one option. There's way more than that though. Yeah. What about 0 time? Could we do 0 time? It didn't go anywhere? Yeah. So x needs to be greater than or equal to 0 because it's not going to go anywhere before we drop it, right? So we're dropping it right here and it's going forever. Okay. And since it's time, can we have partial minutes, partial seconds and stuff? Yep. So all the numbers work. Okay, let's go to the vertex. The vertex is 0, 0. What does that mean in context?
It's falling 0 feet up.
Yeah, 0 drop at 0 time. Right? 0 drop. It hasn't gone anywhere. We good with that? Okay, next we have zeros. What is the zeros? 0, 0. The only time it has not traveled is when it started. Right? Kind of the same for the vertex and the 0 on that one. One thing I want to point out, I just lost my writing because I hit a wrong button, is we've got 1 0, 2 zeros, no 0. Those are all options. 1 0, 2 zeros, no 0. Okay, last one. Sorry, lost that. You can rewind the video if you need it. Domain. So the height of something. Does negative time make sense here? No, so x needs to be greater than or equal to 0. Okay, that's our domain. But does it drop forever?
No.
Where's it stopping? 6. So x needs to be greater than or equal to 0, but it needs to be less than or equal to 6. So you guys seeing why we need both on that? 0 all the way to 6. Do partials work? So this is the time it's dropping, right? This is stopped to ground and everything in between. All right, next up, we have the vertex. The vertex is 0, 576. How did I know it's 576?
The equation right there.
Right there, it's my start. That's where I'm dropping it from, right? I'm dropping it from the 576. And it's, going down to, and it's going to hit the ground at 6. We know it's going to hit the ground at 6 seconds. So my 0, in context, the only one that makes sense is 6. What is 6 in context? When it hits. Boom. Or if it's the fidget spinner. Everybody seeing that in context? You can see the visual of it. Why don't we need any of this junk over here?
It's going up the ladder.
It's like how close it is to the ground. You're not going back in time and it's like going closer to the ground or something back in time, right? So context matters. All right, let's make sure we can do this. We can choose a domain that makes sense. We can model it by looking at graphs. And we can relate the vertex to a maximum or minimum and what it means. I think we can do that. All right, assign seats.